Hello guys, welcome to another video. So today we're gonna talk about Llama 3.1, which was announced today by AI at Meta. So let's start talking about this. It's huge news for the open source community since we now have one of the best models, if not the best model available. Of course, the 405 billion parameter model is gonna take a lot of resources to be able to run. So not everybody is going to be able to run this model, but the 70 and the 8 billion models also got an update and is huge. So starting today, open source is leading the way, introducing Llama 3.1, our most capable models yet. So here we see that they are 128,000 token context windows. So right off the bat, these models are trained on a huge context window, which is pretty great to use for longer conversations. There's a bunch of information to talk about. Let's start by taking a look at the benchmark. So he put this in full screen so you guys can see better. We got updates for the 8 and 70 billion parameters, and Llama 2 9B was the best model just a few weeks ago, and now it seems that Llama 8B it's the better model now. We can see the MLU benchmark score 73 for Llama 3.1 8B, and Llama 2 has a 72, so just barely winning. But when we compare that to Mistral 7B instruct, it's over 10 points greater. And also we saw Llama 3.1 is also winning on this one. We don't have a benchmark for Llama 2 9B here. It also wins on the if eval benchmark. In the encoding benchmarks, human eval, the 8B model got a 72 against 54 for Llama 2, MPP eval plus 72 against 71. Against Mistral, we see a huge jump over 32 points for the code human eval benchmark, over 20 for the MPP plus benchmark. So Mistral was one of my favorite models for a while, and Llama 3 8B it was also one of my favorite models. But now, since this jump, it seems that it makes sense that Llama has the best model for this size. And here we got the 70 billion model. It's being compared against Mistral 8 times 22 billion struck and GPT 3.5 Turbo. This GPT 3.5 Turbo was the model that GPT was using for a while now. It's using GPT-O Mini, which is a new model. So we can see that Llama 3.1 70B wins against GPT 3.5 Turbo, which is absolutely incredible that this model that can be run on a single GPU, with the caveat that it needs to be a high-end GPU like a 3090 or 4090. But still, this model can be run on a home computer, and it's better than GPT 3.5 Turbo, which was unthinkable just a few months ago. And we've seen this huge improvements in large language model. All of these benchmarks, Llama 3.1 70 billion wins. It loses on this benchmark, and it's not that much. For these benchmarks, we don't have information, and it wins the multilingual MGCM benchmark for quite a bit against GPT 3.5. Now we have access to this model. You can download now. One thing that I think we should know that I don't know if many people are talking about is that even the 8 billion parameter model seems to win against GPT 3.5 in some benchmarks or be very, very close. You just need to see this. It seems that the gains for going from 8 to 70 isn't that great, and it would be interesting to see if Llama 3.1 had a mid-size size here. I would say 25 or even 27 billion parameters like the Llama model to fill the gap here, because there's a gap in performance here. So in this benchmark, Llama 3.1 8B wins against GPT 3.5 Turbo. There's a caveat that here they are running on full precision. So for most people to run the 8 billion parameter model on full precision, they're gonna need 20 or more gigabytes of memory to be able to run this on their GPU on a good speed. So yeah, but even so, it seems that very competitive against GPT 3.5 in a bunch of benchmarks, which is interesting. I don't know if many people are noticing this. Of course, the 70 billion parameter model makes sense because even the older model was pretty competitive. So this line, we see the new model, the 405 billion parameter model compared against against the frontier models from NVIDIA, OpenAI, and Anthropic. So in the first benchmark, which is the MLU, we got a punctuation of 88.6, which loses to GPT-4 Omni with 88.7, which is just slightly below that. So it's pretty competitive, and it wins against Claude 3.5 Sonnet. So we can see that now this model is pretty competitive even against the frontier models from Anthropic and OpenAI, and it beats GPT-4. Okay, and GPT-4, we don't know if this is the full 1.8 trillion parameter model, and there's a huge discussion about how cost effective that model was. But GPT-4 Omni seems to improve that a lot. In this benchmark, it wins on the if eval. It wins with 88.6 against all of the models, with a slightly advantage over Claude 3.5 Sonnet. A human evolve, it loses, but it doesn't lose by that much against Claude 3.5 Sonnet. And props to Anthropic, which came out of nowhere and is beating OpenAI in a lot of these benchmarks, which is pretty interesting. Dario Amore, the CEO of Anthropic, really took the teachings of Ilya Sutskever and spent a lot of time on scaling and synthetic data, it seems. If you guys watched some of his interviews, he put a lot of emphasis on scale and synthetic data, which it seems to be the sauce that makes these models perform very well. Also, on the GCM 8K, we see that Llama 3.1 505 billion got 96 and wins against Claude 3.5 Sonnet, but just a tiny bit, but it wins. A small victory against GPT-4 Omni. It's very interesting because we can see that these models are getting really good at math, which is surprising. And even so, there are some things that need to be addressed. It wins on these benchmarks, multilingual MGCM. It wins. Actually, it's a tie, right? This one's a tie. It's not a win for Llama 3.1 405B. But in this long context one, it ties against GPT-4. It wins in the infinite bench by quite an advantage over GPT-4, actually. 10 points, which is a great advantage. So in this benchmark that we see, there's pretty much a tie between Llama 3.1 405B against Claude 3.5 Sonnet, and a slightly advantage over the OpenAI models of both the GPT-4 and GPT-4 Omni, which is pretty interesting because this one model, guys, is open source. You guys can download, of course. Not everybody is going to be able to run this model. But then again, this model is open source. But let's talk about the model itself. There's a bunch of information that we need to go through. Mark Zuckerberg talking about the value of open source. We also know that this model, it has a context length of 128,000 tokens. If we can find more information. So there's this image that shows a Llama 3.1 405B against GPT-4 125 preview, which is pretty much a tie. And wins against Claude 3.5 Sonnet human evaluation. So it's pretty close to those models. And by what Mark Zuckerberg said today, I think they're gonna focus on being the best model. So we're gonna see more competition in this space. Okay, now let's talk about the paper. The paper from Meta. So this paper is very detailed. It has a lot of information. I'm not gonna go through all the information because the video would be even longer than it is. Some of the key takeaways is that 128,000 tokens in this paper. They going through a lot of details about the model. I wanna focus on some of the things that we might find interesting. So this model, which they don't talk about in the blog, is multimodal. Okay, it seems that Llama 3.1 it's multimodal. They talk about here a vision adapter and a speech adapter. There's also information about how these models perform in some of the benchmarks. So here we can see benchmarks on speech recognition. So let me just center this. So we can see here that the 8 billion parameter model seems to be better than Whisper, which is a model specifically made for speech recognition. And I think that is very interesting because it shows that this model's capability seems to be better than models that are trained to do a specific task, which is interesting. I don't know if they plan on releasing Llama 3.1 multimodal soon. That would definitely be interesting because we could be able to test these models for all their tasks. You guys can go to this paper and read it. It's definitely a good read. There's a lot of information about how they went about to train this model, all the infrastructure and all the thing that took to train this model. But now let's focus on testing this model, because you guys can download this model. You guys can go here and download the model. I would definitely recommend you guys to test the 8 billion parameter model, which you guys can go to the Hugging Face repository and download the model. But we're gonna be testing, and we're gonna be testing on the Hugging Face chat. You guys can go here and select the model. We are Meta Llama 3.1 70B instructor model. I don't know about the version that we are running. I think it's the FP16. Okay, it's BitFloat 16. We are running the BitFloat 16 version. I would like to see the 8 billion version, because I think that's the version that most people will be able to test. You can also test on something like LM Studio, but I think that we need a better model. We are not able to download this yet. It fails the model from the Hugging Face community, but I think we are gonna get a good model soon here, which does have a good quantization without much performance loss, because quantization does degrade the quality of the model. So that's something that you guys need to be aware of. So let's start testing this model. I'm gonna start with the most common prompts that we use to test a model like this. So let's go with write me 10 sentences ending with Apple. So it should be able to do this without a problem, right? This is one of the best models that we have there. And it fails, unfortunately. It's not deterministic, this benchmark. Okay, I got the first three right and the fourth one was wrong. It ended with 3. I'm gonna copy this prompt and we're gonna go and give a downvote for feedback for the model. Let's try again. And we probably get right. Sauce, okay, it's wrong. I'm gonna downvote again. Okay, so it's failing this simple prompt, okay, which shows that the model was not contaminated with data from the web. So this is a benchmark that people usually use to test how these models perform on reasoning tasks. Let's go with another one, which is this one is people are using which number is greater, 9.11 or 9.9. So this one is a test that shows how these models fail on being able to do simple arithmetic comparisons. So it says that 9.11 is greater than 9.9, which is obviously wrong. But there are some discussions on why these models make this mistake. One possible reason could be the tokenizer, since the model is saying 11 and 9, and it infers that 11 is greater than 9, so 9.11 is greater than 9.9. That could be one of the reasons. Other reason could be software versioning. For example, Python 3.11 is greater than Python 3.9. So if we go something like which version of Python is newer, if we go with something like this, 3.11 or 3.9, it's the 3.11 is the newer version is 3.9. That could be one thing that is happening, but that's something that we still are trying to understand. Okay, let's try again. Let's see. Write me a seek-to-seek model using Keras functional API. Let's see if it's able to do this. It should have seen enough to be able to do this. So it's using shared embedding. Yeah, it seems to be mostly okay. Yeah, it seems to be okay, but it didn't write the code for the inference part. Also, it gives information on the notes here. Okay, it's not bad, actually. Seems to be reasonable code. Let's try the 405 billion model. Let's try this. Now we're gonna use the full model, which we are not able to run locally. What model are you? Let's see if the model is conscious. You guys can see that it takes a while to be able to start. So I'm a text-based AI assistant of specifically a large language model. I don't have a specific model name, but you do have a specific model name. It's not on the training data. Okay, so the Apple test, right? Ending with the word Apple. Let's do this testing. It does take a while to start generating text. It seems to be able to pass this test. Yeah, it seems that it's able to do so. Yeah, it did pass the test. Was it the issue that I didn't specifically say the word Apple on the other model? Let's do that. Let's switch models. I'm gonna switch models again, and I want to test to see if that's the case. It should, all of them should end with Apple. Okay, it it almost got it right, but the ninth sentence it ended with Pi instead of Apple, but it almost got it right. Okay, so prompting does have some impact. Okay, I'm gonna downvote this. So that's pretty much the video, guys. I hope you guys enjoyed. So today the open source community has a new model to play with. Let's see what people will be able to build with this. I'm hopeful that we're gonna get a quantized version of the 8 billion parameter model that runs better, especially because quantization does degrade the performance. We see some performance loss, which is not close to what we see in the benchmarks, because in the benchmarks they are running on full precision. 505 billion parameter model, it's running on FP8, which is 8 bits per parameter on floating point, which is something that we might see some improvements on this. That would be interesting because the Llama 8 billion parameters model would only take 8 gigabytes to load the full model using FP8, and that would be interesting to see. Also, it would be faster to run that model using an optimized kernel, which the new GPUs from NVIDIA have. So that's pretty much the video, guys. Hope you guys enjoy, and see you guys in the next one. Peace out.